As educators, when was the last time you had to make a decision about what resources you were going to either select or create for yourself to help support the learning of important things in your classes? Probably this morning. It's something that educators have to do sort of constantly throughout their day, throughout their job, throughout their planning. And those decisions are based on a lot of different factors, obviously. Factors related to who your kids are, factors related to what resources you have at your disposal. Well, this module here is designed to help you make good decisions about resources that you're either going to select or create for yourself for math instruction that involves trying to determine whether or not specific types of graphics are going to be most beneficial to help your kids learn the things that you want them to learn. Now, as you probably already know, existing instructional resources present graphics, particularly in math, in a variety of different ways. Here I have two different math textbooks for elementary school, and you'll notice even right from the very beginning, or right from the cover, I should say, it strikes you with a really, really distinct graphic. And if you flip through this particular math book, you can easily notice that there are lots and lots of uses of graphics. Many of them decorative, some of them very, very descriptive, representational. Here's just a typical couple of pages, and it has some graphic representations that are in the forms of graphs, and there's decorative graphics. This is some questions or problems related to baseball, and that's indicated here clearly. So this is a choice. There were choices that went into creating this resource by the people who developed it as far as what graphics they were going to use. And of course, their choices were based on lots of different factors. Some of these factors we're going to be talking about in this particular module. Just by contrast, here's another elementary school math textbook. Again, it has a graphic on the cover. For various reasons, I should say, it's not quite as graphically rich, certainly not as colorful. This was printed in with using fewer colors. I can go to, for example, a typical instructional page for math here. Includes very clear information as I read through it, but it definitely doesn't employ the use of specific kinds of graphics throughout the whole presentation. So which one would you select? Which one is better? Obviously, there are lots of different factors. So in this particular module, you're going to be learning more about the instructional role of different types of graphics so that you can make better decisions about using what the literature refers to in math instruction as visual representations and manipulatives to help meet the needs of all the kids in your class in the best way possible. So with that in mind, we're going to have now a real short presentation over the broad instructional use of graphics in general before you get more specific strategies presented to you regarding actual visual representations and manipulatives in math instruction.
Don't tell me the moon is shining. Show me the glint of light on broken glass. There, that's my best Chekhov. I actually have no idea what Chekhov sounds like. You probably don't either. So for all you know, that could have been spot on. Well, what is spot on is his message to other writers about the value of writing descriptively. And it's kind of a general rule of fiction to show, don't tell in your writing. In other words, be more descriptive with your language instead of just writing technically and to the point. I could suggest that a rule of instruction is show and tell, both in your words and visually. And that's what this part of the presentation is about. Some of the best instructional experiences involve information in which things are shown as well as told. And it's the showing that this presentation addresses, showing in the form of visual representations or images and graphics. So this presentation is about different types of graphics, and once you have a good understanding of this, then subsequent presentations will address what types of graphics best support the types of learning that you want to affect as an educator. Now, the first category of graphics that we want to present are decorative graphics. And these are graphics that add aesthetic appeal, humor, or attention getting within the information presentation process. It might be the art on the cover of a book that speaks to the nature of what the book is about. It might be cartoons dispersed through a dry text. Here you can see a graphic that's probably familiar to you. This is a graphic used on the homepage of Wikipedia. And again, there's nothing instructional about it. It just sort of adds to the overall theme of what that website is about. Here's just a graphic that could be used decoratively within the presentation of some information at the elementary school level. It doesn't necessarily communicate anything realistic or instructional about owls or books, but it certainly evokes some type of feeling that might be attention getting. Here's another graphic that could be decorative. This is a cartoon type of graphic that might be used in a math text or a math worksheet even, just to add some appeal to the information. And unless you're studying the number 3, and this graphic might be useful in identifying what that number is, then it is just a decorative graphic. And in fact, I wouldn't use this for anything more than decorative, even if I was teaching about the number 3, because there's a lot of superfluous information being communicated. But it definitely adds some appeal and some attention-getting strategies. The next category of instructional graphics are representational. And these are graphics that depict an object in realistic fashion. Now, you might not find a realistic-looking illustration of the human heart communicated in an elementary math textbook, but you've probably seen graphics like these in science textbooks. They're very common, and they serve a number of important instructional roles. And this is just a common good example of a representational graphic that depicts an object in realistic fashion. Another example of representational graphics that you might see in a math text is presented in this diagram. In the panel on the left, there are representational depictions of wooden sticks and buckets. That to be contrasted with the representations in the middle panel, which show sort of schematic representations of things that could be sticks and could be buckets. Again, in contrast with no graphics in the panel to the right. Now, if this information as part of the instruction was trying to communicate how to solve a particular word problem that involved wooden sticks and buckets, then it's quite possible that using representational graphics for some learners could be much more beneficial than presenting things in more abstract fashion. So once again, an example of presenting objects in realistic fashion are representational graphics. And finally, this example of representational graphics depicts 3 realistic looking apples. And again, if you were communicating information about the old classic math problem for elementary kids regarding the amount of apples that you are in some ways manipulating, then there might be a good reason to represent them in a more realistic fashion. Again, for some learners, they might be able to better understand the verbal information or the text that's being presented. The next category of graphics are called mnemonics. And you're probably familiar with these in your life in terms of verbal mnemonics, but these are visual depictions that provide retrieval cues for factual information. So in this case, if you wanted somebody to remember what melange means, what its definition is, you might represent a melon and an orange mixed together as part of the word. Here's a very common mnemonic used in math to try to help students remember the order of operations. Again, this is used to provide retrieval cues for factual information, in this case, the information being, well, what order do I need to do things in when I'm given equations that have various factors? So PEMDAS is a mnemonic that is often used. And finally, for mnemonics, it could be something as whimsical as a visual representation along with a little phrase, the man with the big nose, to help students remember what to do when you're multiplying two of these equations or factors together. The next category of graphics are organizational, and these are graphics that show qualitative relationships among content. In this example, we see a graphic representation of the qualities of what is considered the left brain processes versus the qualities of a right brain processes. And just visually, you can see a difference that would help support a general conceptual understanding of the differences between those characteristics. Another example of organizational graphics used in math are Venn diagrams. Again, two good examples representing a qualitative relationship among content. Another category of graphics related to the previous are relational graphics. Now, these are graphics that show quantitative relationships among two or more variables. And perhaps the most common type of relational graphic is some type of actual graph. In this case, a bar graph that depicts the relationship between two variables, in this case, temperature and date. Again, graphs are often used to show quantitative relationships, and when that relationship is characterized as the relationship between amounts of things based on a scale of 100, that's a good example of a pie chart, and a pie chart is a great example of relational graphics. Another category of graphics are transformational. These are graphics that show changes in objects over time or space. Now, the water cycle is probably a concept that most of you learned about in one of your sciences, middle school, junior high school, who knows, maybe even college. But it's a classic example of a transformational graphic that shows changes in water, well, over time and space in this graphic. Another page out of the science text would be the photosynthetic process or respiration or some other important biochemical process that you wanted to depict. In this case, it's another classic example of a transformational graphic. Even some basic diagrams used to help clarify the process and the information presented in a math word problem can be considered transformational. Here's a strip diagram that represents the amount of money that Shantae had before spending a certain amount of it on a book, and it graphically represents a change over time, a change in the amount of money that Shantae had after a certain event occurred. So this is, again, a really good example of a transformational graphic. And finally, the last category to discuss are interpretive graphics, and these are graphics that are used to illustrate a theory or a principle. Now, again, I know that the model of an atom is not something that would likely show up in most math textbooks, but it's a good example of an interpretive graphic that you're probably very familiar with, because atomic theory can be very abstract, but it's almost always communicated with some type of very simple, in this case perhaps oversimplified representation of that theory. A good example that might show up in a math text is an interpretive graphic that illustrates the Pythagorean theorem by, in this case, depicting that if you square A, which is one side of the right triangle, and you square the side B, which is the other side of a right triangle, that you put A and B together, and that will take up the same amount of space as squaring C, the hypotenuse. Now, this would be a graphic that you probably would want to use with a transformational graphic to show that A and B, when you cut them all apart, really do fit inside of C. But again, this is just a good example of an interpretive graphic, one of the different types that are used to help support the learning of certain types of skills and certain types of information in instruction. And from here, you're going to move on to learn more about how different types of graphics can be used to support the learning of different types of skills and different types of knowledge.
What follows next is a continuation of your preparation for learning how to best use specific types of visual representations and manipulatives in math instruction by reflecting on what types of learning in general are best supported by specific types of graphics. But first, some fun practice over classifying different types of graphics based on the examples presented in this video.